Okay, in this question, we're going to talk about the Babylonian method for finding the square root of a number. Okay, so basically, what's the Babylonian method? So it's an old method of finding the square root of a positive number. Okay, so if we assume that we have some square root of some number, s, and we want to find the value of that square root, which we call a. So there is an algorithm that we can use to find this value of the square root. Okay, so the algorithm goes in the following manner. So we start with some guess. Okay, some guess of the value of the square root. Okay, so we keep iterating until we find the exact value, or the closed value that we want, the closest value to the true value of the square root. Okay, we can use some condition when we do that to find that value. So how many decimals we want to be that value to be accurate, or to be close to the exact or the true value of the square root. Okay, so basically what we can do is that the approximate value after n plus 1 step is going to be the average of the previous value plus s over xn. Okay, so this is the previous approximation, and this is the new one. Okay, so this method can help us find the square root of s. Okay, so we can do some iterations, and we can stop using some conditions. Okay, so how many digits do we want? Okay, so we can set some criteria for that to stop. So basically, I'm talking about using some computer, but we can do it by hand. Okay, so our question now is that if our guess, so this is so let's see what we can have here when we start. We have x1, so x2 is 1/2 x1 plus s over x1. Okay, so this is the next step. So our first step is our guess. So the guess that we want to use to start working on trying to find the value of the square root of s. Okay, note here that with this condition here, we have a is positive and s is positive, because we don't care when 0 is, everyone knows the square root of 0 is 0. So in these conditions, we have s squared is a. Okay, so the question is telling us if we said our guess is the exact value of the square root. So if we start from that, this algorithm will run one time only. So that's what we have to prove. That means we're going to prove that x2 is a. Okay, but this one is based on the fact that x1 is a. Okay, so let's work it from here. So if our guess is x1 is a, so for instance, if we want to compute, if we don't know the square root of 25, and if we said that our guess for this one, the starting one, x1 is 5. Okay, so what's going to be x2? Okay, so this is a quick example. So let's say if our guess is the exact value of the square root, what's going to happen? So in this case, x2 is going to be 1/2 x1 plus s over x1. So which is 1/2. So we said x1 is a, and what's s? S in this case is a squared, and what's x1 is a. So therefore we have 1/2 a squared over a is just a. We have a plus a, which is 2a over a. That's a. That means x2 is a, and we get the value. Okay, after one step. Okay, but most of the time we don't get this one right. Okay, we don't know exactly, because we are talking sometimes these values are very small, and we know that. Okay, but if we get some values that are very big, we are not sure that we're gonna get the exact guess matching the exact value of the square root. Okay, but in general, this is the proof. The algorithm will stop in one step if our guess is matching the exact value of the square root. Okay, thank you.